The Eastgate building in Harare, Zimbabwe is another very different, yet still striking example of biomimicry I learned about from the Biomimicry Institute. This building is designed, thanks to the architect's careful observation, in the same way that termite mounds are designed. The termite mound that you can see right here, though it might look rather misshapen, is designed in a very specific way to help maintain internal temperature. So right now in the middle of the day, you can see that there are shaded regions and there are plenty of places where air can keep the nest ventilated and stays at a cooler temperature. And then later in the day, when the sun is setting, those rays can actually strike the side of the nest such that they can heat the nest. And in that way, the internal temperature of these termite mounds stays relatively stable. Using principles like that, architects are able to design buildings in such a way that they save billions of dollars on heating costs, and that in turn means that they greatly reduce the impact of these buildings on the environment. So that's another way that biomimicry can be useful, is in helping us to create more green buildings and more green products. Biomimicry isn't always a happy story. If we take gastric brooding frogs as an example, this frog species, quite a remarkable species. After mom and dad mate, they lay eggs, and then the mom eats the eggs. Those eggs develop inside the mom's stomach. They go through metamorphosis, go from tadpoles into baby frogs, and then once those baby frogs are all grown up, they actually emerge from the mother's mouth. Or at least they did emerge from the mother's mouth until, thanks to habitat destruction and global warming, gastric brooding frogs became extinct. Now we never have the chance to ask what kinds of chemicals do these frogs have that keep those babies from being digested by the acidic contents of the mother's stomach. If we were able to figure out what those molecules were, we had the potential to develop some powerful medicines to help patients suffering from things like ulcers. But because these frogs are extinct, we no longer have that opportunity. There are many species, too, that are right on the verge of extinction if we continue our current behaviors as a society. Polar bears are a striking example, though luckily they're still alive, and so we have the opportunity to learn some very interesting medical facts about them. So take their hibernation, for example. During hibernation, they do not have any weight-bearing exercise. So that is, they're not running around, they're just lying there for months on end, and yet they don't seem to get osteoporosis. So what signals must the osteoclasts in the skeletons of these polar bears be receiving that keeps them from resorbing all of that calcium, putting that calcium back into the bloodstream, and reducing the density of the bone? That doesn't seem to be happening in polar bears, so why could that be? Similarly, polar bears don't pee for months on end. They're just sitting there sleeping. And their bladders are able to break down urea into ammonia, and their bodies are able to synthesize that ammonia back into amino acids again. If a human experiences kidney failure and they have urea building up in their blood, they're toast. So, yet again, if we are able to find out how these bears don't get osteoporosis or are able to turn their urea back into amino acids, we have the potential to really help out some patients. And then lastly, if you think about right before hibernation, these bears get morbidly obese. They're hunting seals. They're putting on a whole bunch of fat tissue, that fat tissue that's going to give them energy throughout the rest of their hibernation. And yet they don't get diabetes. So think of what medical clues we could get from polar bears if we were to study how it is that they get obese without actually getting diabetes. So now we get to the heart of the matter, the real reason that biodiversity is absolutely essential to our survival. Large ecosystems with high biodiversity are more stable than small ecosystems with low biodiversity. This is best illustrated by looking at food webs. So what you have over here on the left is a slightly smaller ecosystem that is slightly less biological diverse in comparison to the ecosystem that is shown over on the right, which is much more biodiverse. As you can see, there are many more species. Now, if we start with this one on the left, let's say something were to happen to this grasshopper population. Maybe some pesticides are washing off from a nearby farm, and that grasshopper population really starts to drop. that has a very negative rippling impact on the rest of this ecosystem, because the frogs and the praying mantises and the spiders, all of which get their energy from these grasshoppers, now no longer have food, and so they're all toast. So there goes the primary consumers, and then of course the secondary consumers and even the tertiary consumers too also aren't able to get the energy that they need. And so you have this rippling effect up through the entire ecosystem where these organisms' populations drop drastically just because of the change in one single organism. Now compare that to if the population of grasshoppers in this ecosystem were negatively affected. If this population started to drop, yeah, it looks like the mice that are over here that only eat grasshoppers would kind of be in trouble. But the rest of the primary consumers, the rabbits, the chipmunks, the robins, which have other sources of food, lest I forget, the deer. And because these primary consumers have other sources of food, and because there are multiple primary consumers, that means that the secondary consumers and tertiary consumers that feed off of them, the owls and the hawks and the foxes, well, yeah, they won't be eating so many mice because there aren't that many mice, but they still have plenty of hares and chipmunks and robins to eat. And so overall, the effect on the ecosystem is not so bad as it would be in the ecosystem on the left. And when we look at our own food sitting on the plate before us, we have to remember that this food, our food, also came from ecosystems, and that those ecosystems, we need to maintain their biodiversity too, and we need to think very carefully about when we get our food, how can we get it in such a way that the biodiversity is maintained, even in the ecosystems that we make, such as on farms. These ecosystems are best kept biodiverse and are most easy to manage if they are biodiverse, even though many farming industries in this country in particular have not realized that yet.